Okay, in this video I'm going to show you the solution to problem 511 from Stallings. And here we start off with a transmitted power of 0.1 watt, frequency at 2 gigahertz, and we're given a parabolic dish which is 1.2 meters in diameter. Okay, so we're given we actually have two parabolic antennas, 1.2 meters in diameter. And what I'm going to do straight out is calculate the area of that dish, and it's the diameter over 2 quantity squared times pi. Okay, so pi r squared basically. And in part A it says find gain of each antenna in decibels. Well, the gain is given by 4 pi times the effective area over lambda squared. For a parabolic dish, we have an effective area given as 0.56 times the actual area, and that's why I calculated the actual area up there. And so I'm going to calculate the effective area 0.56a, 0.56 times pi r squared, and I get 0.633 square meters. Now I can plug that into the gain equation and get 353.5 as my gain. But that's not in decibel units when I use this equation. To convert that to decibel units, I get 25.5 dB. Okay, so there's part A. For part B, it says find the effective radiated power of the transmitted signal. So in part B, I take the transmitted power of 0.1 watt, turn that into 100 milliwatts, which is 20 dBm, and the effective transmitted power is the transmitted power plus the gain when everything's in dB units. So 20 plus 25.5 is 45.5 dBm, or 35.48 watts. And so although we're sending out just 0.1 watt, we're sending it out in only one direction. That is the direction given by the aim of the parabolic dish. And so the effective radiated power is much higher. So if you are standing there watching this source in the direction that the dish is pointing, if you were to interpret that as the power coming from an isotropic source, you would have to say that that isotropic source, had 35 watts of power coming out. Okay? So it looks like that if you interpreted it as an isotropic source. Part C says, let's let the distance be 24 kilometers of free space and find the output power at the receiving antenna. Okay? So we're just going to do the loss budget here. The received power is the transmitted power minus the loss, but plus the gain for each of the antenna. They're the same antenna, so we get 2G there. And we just plug into that equation and get minus 55.6 dBm. Let's see, I used a loss of 126.1 dB, and I calculated that using this equation, plugging in 2 gigahertz as 2,000 megahertz and 24 kilometers as 24 kilometers to get 126 dB of loss. And so that's how you do problem 511. Hope that helps.